Welcome to the video on 3.5 where we're just going to be talking about Venn diagrams. The book has some other stuff in it, but we're just going to focus on Venn diagrams. All right, so let's review what a Venn diagram is. It is a picture that represents the outcomes of an experiment. You can use it, you've probably seen it in other contexts other than probability before, but we're going to use it in the context of probability. It is a box, and there's two circles or ovals or three sometimes, and the circles or the ovals represent the events. So let's suppose an experiment has outcomes 1 through 12, where each outcome has an equal chance of occurring. Let event A be equal to 1 through 6, so all those values are in event A. And event B is 6, 7, 8, and 9. So all of those values are in event B. A and B is 6. So the number 6 is in both A and in both B. It's in their intersection. And A or B is anything in all these guys. And then the ones that not in A or B are these 10, 11, and 12, and they are drawn outside the two circles. All right, let's do some practice of labeling our Venn diagrams. The first thing we're going to try and label or shade in here is A or B. Now, remember, when we're talking about A or B, it's a little different than just like the English usage of the word or. When we mean A or B, we mean it's in A or it's in B or it's in both. My handwriting's bad today, sorry. So any item in A or in B or in both. So that's going to be all this shaded in. Anything that's blue is going to be shaded. That's the set A or B. Now let's think about the set A and B, all right? Again, this is a little bit different than English. You got to be a little more careful. This means it's in both. If you say both in front, it helps. A and B, something that's in both A and B. So that's going to be this dark blue area right here. Let's practice a little bit more. What about not A? So this is everything that's not in A, okay? So that would be all this white part and anything that is not part of the A circle, all this, okay? Not very good at shading, but you get the idea. That's not A. All right, why don't you pause the video real quick and try and think what you would shade for not B. All right, did you get all this stuff that isn't in the blue B circle? All this and this, not in there? All that is not B. One more one. This one's a little bit trickier. Why don't you pause the video and see if you can work out what is in A and B not. All right, are you back? Well, we start with what was in both A and B. Well, that was that dark blue sort of shape here in the middle, right? The intersection shape. So that's A and B. What is A and B not is going to be everything but that, right? Everything but that part. So all this is A and B not. So don't want the dark blue, but everything else. All right, so let's practice using Venn diagrams for probabilities. Now, when we saw our first example way back, the one that was just white, we actually put the elements themselves inside each of the circles and the box, but we can also just put how many elements are in those. And we use the notation N of A for that, number of elements in A. So if A has 10 elements, N of A is equal to 10, right? B has 12 elements, N of B is equal to 12. Oops, I have a typo, sorry. We can fix that, 12. And A and B share 6 elements. What is going on with this? I don't know. This is terrible. Sorry. That means that the number in A and in B is equal to 6. Then it tells us there's 30 elements in the entire set. All right, so let's go ahead and see if we can label the Venn diagram giving this information. And this is one of those times when you don't want to start at the top and work down, because if we say A has 10 elements, we don't know where to put, we don't know, is there 10 here? Is there 10 here? We don't know. So that's not where you start, okay? You're going to start with this area right here. We know that A and B is equal to 6. So there are 6 elements in here, and that means there are 6 in there. That doesn't mean the number 6 is in there. You have to be careful with your notation. Remember, really think about the context. All right, if there are 6 in the intersection and there's 10 in A altogether, that means there has to be 4 not in the intersection. Likewise, if there's 12 in B, 6 are in the intersection, that means 6 are over here in the not intersection part. And finally, there are 30 elements in the entire set. Well, The entire box has 30. Inside A and B together, there's 4 plus 6 plus 6. That's equal to 16. So that means there has to be 14 out here in the white space that aren't in A or B or their intersection or anything. So this can help us find some probabilities. All right, same picture, same label. Let's go ahead and use this information we just figured out to find some probabilities. All right, so what's the probability of being in A? Well, A has 4 and 6 items in it. It's 10 total items in A out of a total of, was there 30 total items? So there's 10 in A. Remember the total was 30. Count up the items in A, divided by the total number of items, we get 10 out of 30. What about B? How many items are in B? Why don't you guys try this one? All right, did you get 12 out of 30 for B? And we can reduce these fractions if we want to. I just don't necessarily need to practice that right now. All right, what about the probability of being in A and in B? A and B. Well, remember, that's that little blue, darker blue ovalish shape there in the middle there. There's 6 items of it in a total of 30, so that's going to be 6 chances in 30. What about the probability of being A or in B or in both? Why don't you guys try and write that probability down? Well, we know it's out of 30, and we know there's a total of 16 elements in A, B, or in both, so 16 out of 30. All right, let's keep going. What is the probability of being in A given that we know it's in B also? All right, A given that B. Well, there's exactly 6 items that are in A given that we also know that it has to be in as well. So that probability is going to be 6 chances out of 12. Right? There's 12 items in B, given that we're in B, so we know we have to be part of B. And of those 12, 6 of them are in A. So the probability of being in A, given that you're in B, is going to be 6 chances out of 12. It's a little bit different way of doing the conditional than we've done before. You can go back and use the formula if you want. In fact, that'd be a good practice. Go do it now, and you'll see that it works out the same way. And finally, what is the probability of being not in A? Well, again, this has no conditional, so we're out of 30 things again. And the things that are in A is 10, so that means there are 20 that are not in A. All right, so we're going to practice computing some probabilities that we've already computed before using other methods. We're going to practice computing those for Venn diagrams, and some people find this a little bit more intuitive. So let's give this a try. All right, we're going to roll the die 2 times. We're going to let A be rolling a 1 on the first roll and B rolling a 2 on the second roll. These are independent events because the first and the second ones don't depend on each other. So we're going to figure out what is the probability of A and B. So that's getting a 1 and a 2. All right, so on this first Venn diagram, I'm actually going to just write in outcomes. Okay, I'm just going to list outcomes. Why did that not work? Okay, outcomes. This is my outcomes Venn diagram. And I'm just going to start labeling. Well, the one, A is rolling a 1 on the first roll. So this would be if I got a 1 and a 1, that would end up in A. If I got a 1 and a 2, it would end up in the intersection because B is rolling a 2 on the second roll. If I got a 1, 3, 1, 4, 1, 5, or 1, 6, those guys would all be in A. Likewise in B, I could have 1, 2, I could have 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, and that's it. Every other possible combination of roll is going to be out here in the universe. I'm not going to write them all in, but let's write a few in. So we could have a 2 and then a 1, right? 2 2s in my B, but I could have a 2 3, a 2 4, a 2 5, or a 2 6. Okay. Likewise, there's a lot of other ones. I could have a 3 1, not a 3 2. So 3 1, 3 2. Oh, not 3 2. 3 3, 3 4, 3 5. I should have made this white box bigger. 3 6. This should not be an A if it overlaps. That's just my careless writing. And then I could have a 4 1, 4 3, 4 4, 4 5. Squeezing it in. 4 6. Well, we've come this far. Let's just keep going. 5 1, 5 2, 5 3, 5 4. I lied. Not 5 2. make that a 5, 5 for space, 5, 5, and 5, 6. And finally, 6, 1, not 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So we can really write those all in. And then over here, I'm going to write down the number of elements. Instead of just the outcome, I'm going to write the number in each, the count of each. So in this intersection, I have 1. In A, I have 1, 2, 3, 4, 5, not in the intersection. In B, again, I have 1, 2, 3, 4, 5, not in the intersection. And then there should be 36 altogether, but let's count. 1, 2, 3, 4, 5, 10, 15, 20, 25. So I have 25 more that are in the white universe, but not in A or B. All right. So now, when I want to find what is the probability of being A and B, I know there's a total of 36 items, and the number inside both A and B is 1. So the probability of that is 1 over 36. So you can use Venn diagrams to compute probabilities. Let's try another example of this. This time we're going to do a dependent event. Same situation. We're going to roll a die 2 times. A is going to be rolling a 1 on the first roll, and B is going to be the sum of the dice is 7. So A is the same as before. So we have 1, 1 is an A, 1, 2 is an A, 1, 3 is an A, 1, 4 is an A, 1, 5 is an A, and 1, 6 has a sum of 7, so that guy gets to be in the intersection. That just looked bad. All right, what else is in B? Well, 1, 6 is in there, but 2 with 5 would be in there. 6 with 1 would be in there. 5 and 2, those are both in there. What else is in there? 3 and 4 and its partner 4 and 3. I think that might be it. 2, 5, 5, 2. Yeah, that looks right. And now everything else is in the universe that's not in A or B. So that would be like if we got a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, or a 2 and a 6. And I know that I'm not really drawing that in there, but I should be. Right, I'm not going to list these all out right now because it takes a long time, but I think you get the idea. Let's go over to this one. This is my outcomes. And this is my counts, right? Number in each, which is going to help me with my probabilities. Well, there's one way to roll a 1 on the first roll and have the sum be a 7. Okay, 1 in there. There's 5 more here. 1, 2, 3, 4, 5. And there's 5 more here. That means there has to be, again, that's 11. We know there's going to be 36 possible outcomes here. So that leaves me with 25 here. All right. So what is the probability of A given we're in set B? So that means we're in B. There's 6 items. How many of them are in A? 1. So the answer to that is 1/6. So when you're doing conditional probabilities, it's a little, sometimes it's easier for Venn diagrams. Sometimes for other people, it's harder. Whatever is the easiest one for you is the one you should go with. But we know given we're in the set B, what's the probability that A happened given we're in set B? Well, there was 1 time it happened out of 6 total things in B. So that probability is 1/6. All right, well, that's the end of this section. Using Venn diagrams, reading Venn diagrams, and using Venn diagrams to answer probabilities.